All right. Let's start with the pull requests.
Yeah, there's a big pile of them here because I finally got through all the stuff from when I was on PTO.
All right. Well, the first one is just came in this morning, and it's pretty exciting actually. This Peter went through and figured out why the op tracker was slow and fixed most of it. Now the performance impact it's not totally gone, but it's like much smaller. You compare on this little chart the blue blob to the green blob on the other side. That's pretty awesome. So I had some style nits, but otherwise all sounds fine to me. Need to run that through testing and such.
Yeah, it'd be nice to get that through the wall clock profiler so that we can actually observe the continued impact of any of it, if any.
Yep. Let's see. I had to patch the blue store to just trim the cache more frequently. Instead of every 200 milliseconds, it's every 50 milliseconds. That was motivated by somebody that had a very small cache and doing a lot of I/O, and it was just not trimming fast enough to like keep the memory down. I don't think we used to trim like every single request, so I'm not too worried about that being a problem. That should make the tail latency a little bit better. Let's see. Backport of some RxDB compaction stuff. An improvement to assert. Hadn't noticed that one. That sounds great. Yep. Let's see. Some power of two stuff from Radoslav. That sounds good. Not sure how much impact that'll have. I'm not sure that those divisions are really the problem, but guess we should find out. Let's see.
Not much. I've took a look on profiling, and the divisions aren't a huge problem. Just they are very easy to eradicate.
Yeah.
With one almost globally with a dedicated type.
Yeah. Okay. Yeah, it's probably just as useful to have the constraints on those settings being a power of two, and if that's actually what we want to enforce.
Yep. Moreover, we could introduce the type to the new type P2T to options infrastructure to have those limitations out of the box, I would say.
Yeah, that sounds good. Okay, let's see. Mark identified something with the OStream stuff for debugging output was slowing down things. I think is that one ready to go? I can't remember. There's some.
I think David pointed out that it was showing it was outputting some debug output more often than previously. I think I forget what it was now. But anyway, yeah, I think that was the only nit with it that was left, maybe.
I'm not too concerned with if the debug output is different, as long as it's like not wrong.
Yeah, that's kind of what I was thinking too. Is
because they're just debug logs. Yeah.
Yeah, I mean, with DO10, you're already bombarded with stuff. So.
Let's see. There's a shard up queue change. I think this one we should just defer until after we merge the other refactor of the sharding stuff. Let's see. Let's start set that closed. Oh yeah, that one was closed. Let's see. Ceph clock now is inlined. That's merged. Some config normalization checks from Peter. That's merged. The observer for the config options that we talked about a couple weeks ago. That's merged. That's great. That should make it really easy to move away from the legacy stuff. More normalized stuff merged. Oh, looks like a couple Blue Star optimizations. How are these? Were these significant impact, Radoslav? Are these worth backporting to Luminous?
Which one? Do you
This
mean
is
on nodes and the stuff?
the avoid overhead of standard function and blob T was one of them.
Could be significant because SDD function requires, in case of taking lambda, it requires additional memory allocation, dynamic memory allocation.
Okay.
And it's quite
then
straightforward, so I guess we might
Yeah.
want to take it.
Might as well. Okay, there's another one too. Mark derivatives of AIO context as final. Those are sort of trivial. We might as well just backport them. If you don't mind doing that, Radoslav.
Okay.
Great. Let's see. Listen, librd object map improvements. Avoiding get val in the read path. That was pretty significant actually. That and the other thing that Mark identified were the two big. What was the net on those, Mark?
So this is with Pet Store that I was testing them. So the in-memory vector object implementation. The MD config T stuff was big. I mean, that was like in each TPOSD TP thread, it was 5%.
Yeah.
So
okay.
yeah, so a fair amount there. I mean, that might have actually been repeated in a couple of places. So it might not have just been 5%. It might have actually been more like, up to maybe 10%.
Okay.
In wall clock time.
Do you mind checking to see if that'll apply to Luminous? Because we want to make sure we have eliminated those same issues there too.
Like do you want me to make sure it works in Luminous, or like we have backported, or
see if it needs to be backported or should be backported.
Oh, so we can look at it there. It may not be as apparent with something like Blue Store. I mean, it might show up.
That's
it just
fine.
might not be
I mean,
as,
it's still,
okay.
Yeah. If it's a trivial fix, then we might as well apply it.
Sure. Yeah, I suspect it depends on whether or not in Luminous we added we were checking some config options I don't think we previously were checking. So it depends on whether or not those new config options were being referenced or not, I guess, in Luminous. That's sort of the question. Yep. I think it was sometime in the last 6 months that we added those and kind of hurt things.
Okay. Oh, looks like there's one from Jean-Peg on duplicate PG log encodes. That sounds good too. That's probably worth backporting too. Another librd thing. More librd. The split threshold went to Joule. That's awesome. And this hash thing we closed because it was a problem with FIO, not really the Blue Star code. Oh, and this one here, the EC backend updated. That one's in the test queue. So, yep, that all sounds good. What else? New cache mode swap. There's a new mode for Rados cache tiering that should look at again. We viewed it a couple weeks ago. I'm not sure what the latest is. What else? There's still work to add quick assist on Intel processors, support for compression. That's still ongoing. Oh, the recovery optimization. That you're looking at that one, right, Josh? Partial object recovery?
Yeah.
Okay. What's the status there?
I think it mostly looks good. There's a few things to be fixed up with the encoding and stuff.
Cool. Okay. All right. I think that's mostly it. All right. Want to talk about the BlueStar cache, Mark?
Sure. So this was motivated somewhat by a bug that came up recently. I don't remember what it is off the top of my head, but it maybe it was that one. I don't know. Maybe it was no, it wasn't just the trim happening more frequently. There was another one too where there was something related to trim, and I started looking at the code for BlueStar's cache, and I guess the thing that really struck me is how kind of the encapsulation is kind of leaky. It feels to me at least like there's just a lot. It's complicated, I guess, and especially yeah. So I don't know how to fix the bug other than that it's made me between that and between some issues with a partner that recently came up where they were having a really kind of it was apparent how confusing it can be to how we kind of deal with BlueStar's node cache, memory for that, memory for RocksDB's block cache, and then also having memory available just for caching data in BlueStar, and how we kind of try to divide up the ratios between those and limit RocksDB's cache at some point. It's just kind of, it's not only hard for users, I think, to kind of understand all of that, but even for us, we've got this kind of scheme that I was responsible for implementing to try to kind of make a sane default for how we divide all this up, and it's clear that it's not handling at least this particular partner's use case very well. So we could try to make that better. We could try to make it smarter. We could try to divvy up things more dynamically and make it so that we're balancing hit rates in our cache and RocksDB's cache, or maybe just try to make something that's a little bit better, a little bit of a better default that's still pretty simple. But even at that, it all feels crazy to me. So the quest that I'm on now is to try to see if we just kind of rip out BlueStar's cache entirely, if we can identify what the pain points that it's solving are, and then fix those instead of having our own cache, and just rely on RocksDB's cache for metadata. I don't know if that's sane or not. It might not be. We might still need our own, but I want to at least kind of get a better idea when we don't have our own cache of what we're fixing. Yeah.
So I think there are two. I think it's important to separate out metadata and data. So the problem we're having here is the case where we're not caching any data. It's just metadata, and we weren't divvying up for. If you gave the OSD lots of memory, it wasn't giving RocksDB enough of the memory. We basically capped the RocksDB memory at, I think, 512 megs or something really small, and gave everything else to BlueStar, and that was just a bad decision. I think in retrospect it doesn't make much sense.
The only thing is that that's what the testing was bearing out for us, even with a fair amount of stuff.
Yeah, but that was before we put the we fixed the
Bloom
options
filters,
so that the Bloom filters were enabled and accounted
Correct.
for in that cache, right? So it was that we made a decision, and then we made something that affected that decision, and we didn't revisit the decision. So,
yeah, exactly.
So we have to fix that regardless. But the thing is, if setting all that aside, eliminating the metadata cache in BlueStar is basically the basic trade-off is if you eliminate it, then you're basically trading the overhead of maintaining that cache in memory versus the cost of decoding the data that comes out of RocksDB every time. Mm-hmm. And we did quite a bit in BlueStar to make that decoding much faster, but it's still slow, I think. Objectively speaking, it's still too slow. And I don't know that that's something we can fix in the short term. I think it needs a pretty fundamental like rethink and redesign of how the data structures are laid out in memory so that it matches the representation in RocksDB, so that there isn't like a decoding stage. We can just like map it into memory and immediately use it.
One thing I do want to point out, though, that we don't have a lot of data on is that when we've encoded the data, we can fit more in RocksDB's cache than we can in the BlueStore ONode cache.
That's true. Yeah.
So for customers that have a lot of objects, it may be better to have more things in cache, like and eat the encoding overhead and decoding overhead than it is to use BlueStore's ONode cache. We don't really know. It looked before when we did this testing last like giving BlueStore's ONode cache all of the memory we could more or less made sense as long as RocksDB had some like minimal amount for probably indexes at the time, and now indexes and filters.
Yep. So if I remember correctly, so we have BlueStore KV ratio set to 0.99 or whatever. So right now we're steering almost everything to RocksDB until we hit the cap, which is 512 megs, and then everything goes back to BlueStore. So it's really that cap that seems like it's a problem. I think it feels to me like the focus should be what is the actual cost of maintaining that cache, because that's the part that I don't really. It feels like we're sort of making decisions based on a fear that it's expensive, but I don't know that we have any good data about what the overhead of actually maintaining that cache is. So like if you have
we know the filters alone eat up 20 bits per key with our current settings.
That's all in RocksDB though. No, I'm talking about the BlueStore cache.
Oh, the BlueStore cache. Sorry. Yeah.
Do we have a good understanding of like how much that actually costs? Because there are sort of these confounding issues. One is that we have to have some tracking of in-flight requests, and that's handled in the cache. So it might be that the workaround is just to like steer all the memory towards RocksDB, and then BlueStore just caches only what it has to. That requires basically no code change, or very, very little code change, and might be enough as long as it keeps all the cache structures small. So all the lookup tables the hash tables are small. It's only in-flight stuff. It should be hopefully really fast. But again, we need to sort of figure out what the cost is there. And the second thing is that the only way to cache data is to also have the metadata that it dangles off of. So if there's any kind of data caching enabled, then that doesn't help, right? We have to have RocksDB tracking that in memory. I think that's important for SFFS workloads and for RGW workloads, not so much for RBD because there's the client-side caching there, and also the VM and everything else is caching at the file system layer. But for RGW, hot objects should get cached on the OSD, and for SFFS, well, maybe less important for SFFS, but for any client sharing, that cache will be helpful.
RGW is one of the cases where I'm worried that having a kind of not being able to dynamically change the RocksDB cache hurts us, right? Because you've got so many more key value pairs potentially with OMAP that we don't know how much we need to be able to keep all of the indexes and filters in memory.
Yeah, and it seems like the wildcard, the variable that we don't understand is how much memory those Bloom filters and indexes are going to be versus actually caching the key value data. But it seems like that mostly matters if, we just don't really know how big they're going to be, because it's really a question of the size of the data set determines how many Bloom filters there are. And that depends on how much OMAP data there is or isn't, I guess. And we have a specific amount of memory. Yeah.
And it even kind of gets more weird, right? Because you load, well, I was going to say you load Bloom filters in with the SST files, but that's not true because we're keeping them in the block cache. So you have like a Bloom filter for every SST, right? So depending on the size of your SST file, you may be paging stuff in different sizes, right? You might have like if you have a big SST file, you've got a big page in for the bloom filter if it's not in memory. Whereas if you have like small SST files, and you have less to load in at once. But it's good and bad, all kinds of trade-offs. I think we want. Go ahead.
Go ahead.
I was going to say, I think we always want indexes and filters in memory if we can help it, though. That's the number one priority.
Yeah. So I think that my gut says that the simplest thing might be good enough, and that's basically just to fix that stupid cap. And so it's instead above a certain threshold, you just sort of devote 2/3 to RocksDB and 1/3 to BlueStore, or vice versa, something like that. My guess is that that's going to be good enough. But if it's not, then we should be able to ask RocksDB how many SST files there are and how big they are to get an estimate of how big those bloom filters are, so that we can adjust the cache based on that. I'm just not sure that it's going to be worth the complexity to do that. My guess is that we can do the simple thing and it'll be good enough.
I kind of wonder, generally speaking, in a variety of different situations, if we want some kind of mechanism where we can map some kind of inputs to different outputs, right? Like say, this is the hit rate of the bloom filters, this is the hit rate of the key value data. Give us memory based on these numbers that we're giving you. And that seems like it's very generally, that kind of a process is really applicable in a lot of different places and stuff.
Yeah, if you have a model for what the cost of a miss is and the cost of a hit, and you have the hit rates, then you can build a model based on that, and you can do an optimization problem where you decide how to allocate the memory on that. That's true.
Yeah. I wonder because if we keep the BlueStore ONode cache, and we've got that there where we have to decide how much memory that thing has. We've got the RocksDB cache where we have to decide that. We've got some other buffers in various places. If I recall, in let's see, the OSD code.
The OSD has the OBC, object context cache. I think it's like fixed size. I think it's just fixed at like 100 or something. I think it's not really, doesn't do anything fancy.
What I'm wondering though is if we can do something like this, then users don't even need to think about that, right? They don't have to wonder, this cache or this buffer is 100 megabytes.
I think, to be clear, users should never have to think about any of this. I want users to have one knob that says this is how much memory.
Yes.
So I think it really comes down to how sophisticated a model do we think we need. And it's basically complexity versus diminishing returns. So we can do something sort of a trivial set of heuristics like we currently have that are hopefully good enough, and we make them like just good enough so that they're good enough. Or we can invest, a lot of effort into like online optimization, totally whatever, get super complicated.
Could it be even something as simple as you have different things that say RocksDB, we have some kind of little piece of logic in there that says, here's how badly I think I need memory based on some scale, from 0 to say 1.0 or something, and say this is how badly I think I need memory, and then we give it memory based on how much it thinks it needs memory and how much other things think they need memory. I don't know.
Yeah. I think what you were saying before is the way to look at it, where if you look at the hit rates at the various layers of caches, and if you can determine what the cost of a hit or a miss is, then you can optimize that function, that system or whatever. But I think that it doesn't necessarily mean that we have to like do that optimization online in a running system. I think it's sufficient that we basically build our own model and we decide what the sort of extreme workloads are. So for example, all RBD, no OMAP, it's all block data, whatever, and then we like fill a device, and then we figure out what the right allocation of memory between BlueStore and RocksDB is, and then we take the other extreme where it's like all RGW indexes, fill an entire device, and we figure out where that balance is, and then we just pick something that sort of tacks somewhere between those two extremes, without necessarily does that make sense?
I think it does if you assume that a cluster's workload isn't going to shift dramatically in runtime between like an RGW and an RBD workload, like predominantly one shifting predominantly to another.
Well, I think even if it does, if we choose I'm just guessing here, but my guess is that the surface area of the thing that you're optimizing is such that whether you're steering like 80% to RocksDB and 20% to BlueStore, or 80% to BlueStore and 20% to RocksDB, doesn't make a huge level of difference. It's only when you get sort of in the extremes where you have not enough for RocksDB or not enough for BlueStore that things really go south, like they did in this case with the partner. And so as long as we sort of stay in this middle ground, then we can pick a value that's sort of middle of the road that doesn't run off the rails for either of the extreme cases. Like it still does good enough for the all OMAP case, and it still does good enough for the no OMAP case. Then we might get another 10% if you're twiddling trying to optimize it perfectly, but I'm not sure it's worth.
Yeah.
Especially for something especially for the case where we just need to make sure BlueStore doesn't break, right? We need to make sure that, or not BlueStore, sorry, Luminous. We need something that we can backport. We just tweak the policy so that it's going to be okay for everything.
Yeah.
And we don't want to introduce this whole other level of self-tuning monitoring or something.
So I agree with you there that something very simple for Luminous, absolutely. We don't want to backport big change. I do wonder though if we're still going to have a problem where you have very different requirements for how much cache RocksDB gets depending on what you're doing. Like in an RBD case,
that's the big question, right?
Yeah. Yep.
So I think the way to answer that is to basically take a big SSD and fill it full of OMAP, and then a big SSD and fill it full of 4 meg objects, and just see, right? We just need to do it because it's hard. We can't really speculate what it's going to be.
Mm-hmm.
Well, you can, but it's not going to be right.
Even in the 4 megabyte object case too, if it's really fragmented, we're still going to have a lot of key value pairs, right?
Yeah, but we can. Yeah, but it's going to be work. Oh. I'm just thinking what the extremes are. So the extreme in one way is going to be RGW objects. So they're all 4 megs and they're written sequentially and they're not fragmented at all. And the other extreme would be 100% OMAP, tons of RocksDB keys.
Yeah.
Maybe there's a third point that's very fragmented RBD because it's slightly different key value data, but I'm not sure that I think it won't matter because I think that the important bit is the size of the RocksDB Bloom filters.
Yeah. And the ones the Bloom filters that we really, really need, I think, are probably when we're setting or checking adders for when we're doing writes. We're looking to see if stuff exists already. On every single write we do 3 of them or something.
Yeah,
so
yeah.
That's really what we're talking about being the primary thing we want, a super high.
And it's probably the case that RocksDB just doesn't isn't distinguishing between that part of the key space and the key space that's like just full of user data. And so it isn't preferentially keeping those Bloom filters in cache versus the other ones. But ideally, we would have all of them in cache, right? Because it's going to be. So I think the simplest case would be we can size it so that we can keep all the Bloom filters, even if you have a complete device that's just full of. If you fill an entire device with key value data, we'll still be able to keep them all in memory. That'd be ideal.
Yeah.
And so that's the question to answer.
We don't even really want Bloom filters at all for any PG log entries that end up getting into level 0.
I don't know. I don't know how compaction works. They might be it there, but I think that's a small piece of the. Maybe not. I don't know.
I don't think it is actually. I recall on a different different partner or customer. I don't remember workload when they had a big, much bigger than our test environment here. I recall seeing a lot of work being done creating and working on Bloom filters, and I suspect it was for pglog work with all of the key inserts that are coming in with pglog. I mean, it's a huge amount of our total key insert workload is pglog updates. I suspect a lot of that work creating those things I don't think we even need it, right? I mean, there's no point. We don't read that until we need to on a startup. But
did we put it in we have it in a separate column family now, right?
Yes. Oh, we have OMAP in a separate column family. I don't think pglog specifically though, right?
I thought we did. I thought we put pglog in our column family.
Maybe I just misremembered.
We at least experimented with that.
Yep, PG Meta OMAP. It has its own column family just for the PG logs. So if we can disable Bloom filters on a per column family basis, then we should just do that.
Yep, that might help as well.
Can you look at that one?
I can. Let's see.
Okay.
Right. So that's a good thing.
It feels to me like the two action items are that disable Bloom filters for PG Meta items, and then we need to deploy and populate a OSD or small cluster or whatever that's just completely full of probably RGW index data or something, or some sort of simulated OMAP data. Just completely fill it up. And then we can look carefully at what RocksDB did. How big the Bloom filters are, how much memory they would take to cache them all, whether we can cache them all, how much memory we need given the size of the device if we wanted to cache them, and so on. Because that'll tell us whether it's just a matter of increasing the limit to 2 gigs instead of 1 gig, and they'll all fit. Maybe that's enough, or maybe it's impossible for them to fit, and we have to do something clever where we prioritize different types of Bloom filters or something else. But we need to get the data to figure out how big they are in that case.
Yeah, and I actually don't know. I don't actually know if RocksDB gives us that, what the hit rates on the Bloom filters are. That's part of this is finding that out.
Yeah, but we should be able to figure out how big they are, right?
But we know how many. Yeah, I mean, we know how many key. Well, we can
there
find out. Yeah, how many keys there are. Yeah, and then we can calculate it.
We can figure it out from there. Yeah.
Yeah.
Yeah,
I know RocksDB. Oh, go ahead, Ben.
Sorry, I don't want to interrupt. Go ahead.
I was just going to say, I know RocksDB will give you estimates on how many keys are present. There are kind of some weirdnesses, I think, when you have duplicate keys in multiple levels, where it's not exact what you have and what you don't. I don't know if there are offline tools where we could just shut everything down and then have it go by and go through and just get everything. But
I'm not sure that how many keys is actually what we care about. because the user doesn't know how many keys. We don't know how many keys. What we know is that we have a 10 terabyte SSD or whatever, a 30 terabyte SSD from Samsung or whoever it was. That's what we know. And so if we fill, and the question is, as an operator, I have this SSD. I know I'm going to be using it for RGW antics. Is how much memory do I need for my OSD for this size device? So we should just fill it with sort of representative OMAP data. So something that looks like a generic-ish OMAP workload for RGW probably, and then go from there.
From the perspective of knowing how much memory the filters are going to take, don't we need to know the number of keys to figure that out, though? Like, we have to look at how many keys we generated when we ran this workload, so we can know at 20 bits per key how.
If we're gonna figure this out like on a napkin, then we can count the keys and figure out how many keys fit into an SST table, and then how big the Bloom filter would be per SST, and we could figure it out that way, and like multiply times 3 or something for all the right amp or whatever that happens. Or we can just have a workload that generates the keys that we care about, not even know how big they are, and just fill the device up. And I'm kind of leaning towards filling the device up because that will capture any other effects that we didn't think about, right?
Okay, and then how do we find out
how RocksDB behaves in the real world and see what it needs?
And how do we know whether or not the Bloom filters used more memory than was available in the block cache?
We have to like look at the logs to figure that out. I'm not actually sure. So we can look at BlueFS to see how many SST files there are and how big they are, so we can actually see that. I assume we can look at an SST and parse it out and figure out how big the Bloom filter portion of it is. It's probably like in the header of the file. It starts with the Bloom filter or something. I'm not sure. So we might have to write out something to like dig into the guts of the RocksDB data to see that data, but I'm assuming that we can figure it out since it's open source.
Yeah, well, it'll be different since different column families will have different SST files. We'll have to kind of, we can't just look at like one SST as representative. We'll have to figure out what the ratio of different things are and what they look like.
Yeah.
I don't know if that's better than the like trying to find out how many keys total are in the database, because then you can just apply the one, kind of.
Yeah. Well, we could do both.
Yeah, maybe.
But it feels like we can't skip the part where we actually look at the actual RocksDB behaving in the real world. we can't just do the napkin calculation and then assume that it matches reality. We have to actually check. But,
yeah, sure. Fair enough. Okay, sounds good.
Okay.
There's only one other little thing I had here, which was that I don't have it up yet, I guess, the wall clock profile, but when I was doing some of the pet store work earlier, I did a wall clock profile on FIO with the librd plugin, because that was actually the bottleneck at some point, was having just one client wasn't enough. I had to scale up to multiple clients, and looking at it, it looked like a lot of time. Well, poll might have been a bottleneck. We actually were spending a lot of time just polling. It might be that something like ePoll would be faster. But then also there was some random other stuff in here. Looks like objector locking was maybe some of it for op submit in TP-librd. Calc target, spending some time there.
The crush calculation.
Yeah. Then just lots of stuff in the async messenger too. Objector handle OSD op reply, locking the finisher queue there. There's some finish op.
I think it's been about 4 years since we optimized the objector code, so it might be worth a fresh look. I think Yehuda did a big rewrite when we were working with SanDisk in like 2013. I think that was the
Yeah,
last.
I have a big rewrite for that using ASIO or the networking TS.
Okay.
In the pipeline. I just haven't been able to get back to it yet because I've been doing stuff
Other things
for customers.
Yeah. Okay.
Also, encode, decode. There's a fair amount in encode and decode of MOSD op. So encoding that, decode message. Actually, CRC calculations were not insubstantial there. In any event, there's a variety of things here on the client side that probably could be looked at and improved. So,
okay.
Yep, that's all.
Okay.
That's all I've got.
Okay. I guess short-term fix for the current tuning. I think it seems pretty clear that our decision to just put a hard limit on the amount of data that we give to RocksDB isn't right.
I maybe we should get the data back from the user though, because it's also entirely possible that these are misses in BlueStore's ONode cache, and that we're just
Yeah. Okay.
Yeah.
So there are a couple other pieces of information. One, when they turned on the BlueFS buffered read, it vastly improved things. This is something that could be because the block cache in RocksDB wasn't big enough, but it could also be that RocksDB is still stupid about compaction, where when it does compaction and it writes new SSTs, they don't go into the cache, they only go to the device and has to go read them back again as you start faulting against them. They haven't been super excited about like changing that because most people run RocksDB on top of a file system that has its own page cache, and so it doesn't matter that much. So I wonder if we should just change that setting to default to on.
Yeah, I think if I remember right, I've actually got data showing that buffered reads was far, far better too. When we were testing Radoslav's async read PR. Let me find that, because I think we've got.
So while you're doing that, I just have a question about that, because if we see that buffered reads is better, that basically says we're not caching the stuff that we should be caching, right? And
well, two things.
Yeah.
So two things. So yes, there are two reasons why that can happen. One, because the RocksDB cache isn't caching what it should because it's too small, which I think that's what's going on here. But the other cause, which we can't fix without fixing RocksDB, is that when RocksDB does its compaction, it's taking all these SST files that are warm and in the cache and everything, and it's writing new ones that are compacted, and it doesn't put them in the cache, it just writes them to the device. And so immediately following a compaction, you have a whole bunch of cache misses that have to fault everything hot back in again. And that's a common problem with RocksDB and LevelDB and a bunch of these things. I've reviewed papers with weird, complicated schemes trying to like mitigate that effect with LSM trees. And when we talked to RocksDB about that, they said they don't really want to just dump the newly compacted stuff into the cache because it'll push out all the other stuff that is legitimately warm, and the newly compacted stuff may or may not be warm. They don't really know. And so otherwise, every time you do compaction, you'll just basically like throw out everything in your cache. And their cache basically wasn't smart enough to have. I think they're using a straight LRU, and so that's the problem. If they're using like a 2Q or MRC or whatever, one of the more sophisticated LRU type caches that has multiple chances before you get kicked out, then it wouldn't be a problem. But they don't. So, or would be less of a problem. But basically, BlueFS buffered reads true sort of avoids that issue because you have page count for some period of time. The reason why I was pushing to get that off and why we finally turned it off was because I wanted to eliminate that entirely, so that we would have just to simplify the code, mostly, and so that we wouldn't have a disparity between when you're running on SPDK and when you're running on a kernel block device. And I think that disparity doesn't matter that much, and the code's already there. It works fine. So if it helps, we should just make use of it. But that was why I pushed to get it turned off.
Okay, but if you're doing that, doesn't that mean you're buffering stuff twice? Because you're buffering it essentially in the Linux buffer cache and also in the OSD.
Yeah. Yes. But the Linux buffer cache is sort of free memory because we're not using it anyway, because all of our other caches are in the process. And so anything that sits in the Linux buffer cache is memory that we wouldn't be using anyway. So it's free. As far as we're concerned, I guess. Right? You might be crowding out, something else in the PH cache for a file system or something, but I don't think we care about that.
Yeah, the buffered read bit is kind of in some ways nice because it lets us not have to be quite as precise with how much memory we're giving BlueStore either, right?
Yeah. Well, yes. Right. Because basically any other memory left over in the host, BlueFS will just cache RocksDB.
Yep.
That's right.
Yep. But I think there's a lot of situations where we're going to have customers that are not going to be able to very precisely define how much memory BlueStore gets.
Yeah. Okay. So that I'll open a PR that turns that back on and be back for it. I think that seems like a no-brainer. But the other thing is, let's see if I can remember how this works. So the cache tunables for we have cache meta ratio, KV ratio, and KV max. So we have meta ratio, which is 0.01, KV ratio is 0.99. Data ratio is inferred from those. It's just 1 minus the other two, which is defaults to 0 because just 1 minus the other two. And then we have KV max, which is currently 512 megabytes. Basically, if you have less than that amount, basically it'll obey these ratios in divvying up the BlueStore cache until KV max hits the max, at which point it'll stop giving anything to RocksDB. That's the current behavior.
Yep.
But I think we should change. I think we should either just get rid of it, and so we obey those ratios all the time, or we should change it to KV min, where if it's below KV min, because look at our settings. Our settings basically say give everything to RocksDB. So if we change it to KV min, where if it's below that, then all of our memory goes to KV, and then if it's above that, then we obey the ratios. Because right now these ratios are basically meaningless, right? So if we change it to KV min, then we can change these to 0.5 and 0.5. And so if we have less than 512 megs, we give all of it to RocksDB, to RocksDB. And then once we get above that, then we give half to RocksDB, half to BlueStore.
We
Does that make sense?
We don't necessarily want to give half of it to RocksDB and half to BlueStore, though, because that was the behavior that we had previously, where we were having a lot of O-node misses when doing on fast devices. We had something more along those lines, and we kept on through a variety of steps. We kept on giving more and more and more to BlueStore's cache, to the O-node cache there.
Right, but that was before we had Bloom filters.
That's true.
And so I'm just saying that decision has since bit us in the butt. So again, this is going back to our original discussion where we can have a complicated model that tries to give exactly the right amount to RocksDB and no more, and then everything else to BlueStore, or we can have something sort of middle of the road, simple. Mm-hmm. And I'm just guessing that half and half is sort of splitting our risk there, right? If you have 3 gigs to give to the OSD and you give 1.5 to each, that's not going to be that different than if you had 5 gigs and you gave all of it to or whatever, the other way around. If you have 5 gigs and you give half and half, it's not that different than if you had 3 gigs and you gave all of it to RocksDB, right?
I don't know
Or
if I
vice
believe
versa.
that statement, but I'm trying to see if I can find some of the old testing, and legitimately this is without the Bloom filters in the cache, so it's not
Right.
strictly relevant, but it wasn't real. It was, you know, what we have now was kind of the optimal at that point.
Before, but we got a huge boost from the Bloom filter. So I guess the way my sort of intuition here is that at worst, we're at the worst case here if we're just splitting it 50-50, at worst, we're half as good as we could be. That makes sense? So in the worst case, we're like only making 50%, getting 50% of the value out of the memory. Like if you compare it to giving all of it to BlueStore, which might be the win, or giving all of it to RocksDB being the win, we're sort of giving like half of that value by splitting our risk. It's like putting half our money on red and half on black, I guess. And when you start talking about giving multiple gigabytes to the OSD, which is what we're doing with NVMe, we have the default cache size is 3 gigs. This is going to be no worse than having the perfect. If we have 3 gigs and we split it 50-50, it shouldn't be worse than if we had 2 gigs or 1.5 gigs and we perfectly allocated. We made the perfect decision.
Yes, there's just a big difference in our performance when we have 1.5 versus 3. I mean,
yeah, or 5, whatever. But
Is are very binary. Either you have enough or it falls off a cliff. That's the problem.
Yeah, which is why we need to do the whole analysis of what the Bloom filter sizes are in the worst case, I guess.
Yeah, I think the takeaway from this is that now that we've got Bloom filters in the RocksDB cache and we've made other code changes too, it's probably worth retesting all of this, figuring out kind of what we expect given how many O nodes people have. Yeah.
But setting that aside, previously we had this. The current behavior is that up until 512 megs, we're giving all of it. We're giving 99%, so we're effectively giving all of it to RocksDB. I don't think that's any different than basically changing that KV max to KV min, so that anything below that we dedicate all of it to RocksDB. Is basically no change in behavior. All that's changing is sort of how we allocate things beyond that. But it still feels like it's the right direction to go in.
Yeah, it very much changes the behavior when you are in large memory situations, certainly. Yeah, and maybe that's what we want.
Right now, below 512 megs, it all goes to RocksDB, and above 512 megs, it all goes to BlueStore.
Yep.
And so we could change it to KV min instead of KV max 512, and below that it all goes to KV. And then above that, we change meta ratio to 0.99 and KV ratio to 0.1. We basically flip those two, and it would be the same behavior. But the new way, having KV min instead of KV max, would give us the flexibility to decide what happens above that 512. Whereas right now we're just stuck. We don't have a choice of whether it goes.
Yeah.
And I don't think we have I don't think there's any question that below that threshold it should all go to RocksDB, right? I don't think that's not a question. So,
and that was what the testing bore out too, is that you needed at that point at least that much memory to be able to get reasonable performance. And then it was exactly what Ben just said. It was a cliff, right? Anything more at that point, more or less, and it wasn't exactly 512. It was probably more like 400 or something. At that point, giving more to RocksDB didn't help. It was better just to give it all to BlueStore. I suspect that's going to continue to be the case, where there's some amount of memory RocksDB needs. You give it that, and then after that, it's better to give it to BlueStore. That's what it seemed like the testing showed when we originally did this. I think is probably still the case. It's just that RocksDB needs more now that there are Bloom filters there.
Okay. I'll take an action item to prepare a pull request that changes KV max to KV min and just flips the options around.
Sure.
Okay.
So one question though is if we are doing buffered reads in BlueStore and we can solve or at least identify pain points, if it's encoding or if it's locking or something else, is there any good reason to split the memory anymore and actually have the BlueStore cache at all? Because it still strikes me that it's a lot of complexity, it's a lot of code, and I don't know that there's a whole
data caching. In order to cache any data at all, we rely on the metadata cache because the data is associated with the metadata. So we need most of that complexity just to track in-flight writes. We could throw it all away and rewrite something that's probably simpler, but it wouldn't be that much simpler. Like we would get rid of the LRU, but all the rest other data structure would be the same. We'd have the same lookup tables, basically. So I don't know that we would win that much. And we still need it for in-flight writes, and I think we still need it for if we want to have the OSDs ever cache any data ever, and I think we do for RGW and for probably for Ceph.
So if we're doing buffered reads and if we have the O node cached in RocksDB and along with all the other key value stuff, where would you expect to see pain points? If we didn't have the O node cache, is what I'm wondering.
A hot RGW object, right? If you have one object that has, it's the latest. I think we had something on Dream Objects several years ago that was like it was something stupid. It was like a Minecraft tarball, I don't know, whatever. It was just some gaming thing. It was just some big file, and it got linked somewhere, and then a bazillion things were hitting it, and every single request goes through RGW to the OSD. And the OSD wasn't caching it for some reason. I can't remember what it was at the time. And so there was like a disk IO for every single get, and there just was no caching anywhere in that stack. So RGW isn't caching on the client side. You could put like a caching web layer in front of it, but I don't think that's sufficient, right? With file store, you can use the page cache, but with BlueStore, like it's direct IO, you need a cache in there somewhere.
Am I for buffered reads? Am I not understanding what that does properly?
It's BlueFS buffered reads, so just the RocksDB is going through the page cache, not BlueStore itself. Still does direct IO for the data path, right?
Okay.
There is also an option to make all data IO in BlueStore buffered, but that's way slower than direct IO. Because you're copying data in and out. All bytes in and out of the system get copied in and out of the page cache. There's a huge amount of overhead associated with that. Not a huge amount, but it's slower. You can go measure it, I guess, if you wanted to.
I'm trying to remember. I need to look at what. So there's a link in the chat for some of the tests, and if I remember right, when we switch on buffered, that is
different. That's different. You're thinking of BlueStore default buffered read and default buffered write. That's a different setting. That's determining whether BlueStore is caching an unhinted IO in its data cache or not. So that controls what BlueStore's caching behavior is, but the actual IO to the device is always direct IO, AIO.
Do not currently have any options for enabling buffered reads in BlueStore from the disk?
They might be there. They haven't been used since we were developing it years ago. So buffered reads aren't asynchronous. So a buffered write will go into the page cache, and hopefully won't block. But the IO doesn't get initiated immediately until you actually do the fsync, so you're actually delaying IO, so it's probably going to slow it down. There's also all the data copies into the page cache that you avoid with direct IO. And on reads, there's no such thing as an asynchronous read that's buffered. So reads become blocking. So all the AIO stuff that we did on the read path, but we throw out the door if we use buffered reads, because buffering on the block device, because it's right. And all of the other thing is that all of the threading, it just totally changes the structure of BlueStore, because right now we queue an AIO and then we continue, and then there's a different thread that picks up the AIO completions and does. That's completely different, because there is no, the AIO thread doesn't do anything more anymore if we're not doing AIO. Yeah. I'm 99% confident that we don't want to do that. Right? The whole premise of BlueStore was that we're doing direct IO and we're not using the buffering stuff. The change design pretty significantly.
I'm trying to remember what I need to go back and look at the configuration files when these were run, but I just want to make double sure that we were not setting anything there that.
Yeah, I mean, I don't even know what the configuration option is, or if it still is in the code, because I don't know that we've ever. I think it's bdev AIO, and yeah, it's bdev AIO and bdev. Yeah, I don't think we've ever tested it. Yeah, not something we ever performance tested. They're for non-Linux hosts, basically.
I have bdev AIO commented out in my Ceph.conf, so I've tested it at some point. Let's see. bdev AIO equals false, but it's commented out in this particular test that was run. Let's see.
We're running up on an hour here. Is there anything else we want to cover before we wrap up? Or?
I don't have anything. Anyone else? Last minute?
Yes, just a minor note. I'm currently starting the some of the investigations we talked about the other day of trying to see if we can find trying to look for a few points where we can get a short-term win to keep the customer that shall not be named happy regarding some of the PG log and OMAP stuff.
Cool.
Okay.
Cool.
Is that around? What's the strategy?
The strategy is basically that to see if we can come up with a way that will allow them to buy some NV RAM and get a big benefit in a couple of the pain points from RGW that have been bothering them as a result. Basically, specifically with versioned writes, there's a whole lot of transaction overhead, and if we could temporarily move some of that through a fast medium and then move it to a slow one when it settles, as well as making PG log not compete as much with everything and everything else, that should make them not hate us.
Are they on FileStore?
Unfortunately.
Yeah. Yeah. I mean, they can have NVRAM backed OSDs for the OMAP pool. If they're not, are they already using SSDs?
I believe they have some SSDs. I'm not sure of their configuration of that configuration. We're basically looking at. I mean, I'm sure they have SSDs. I wouldn't even look at code changes until the OMAP is 100% on SSD, because that's it. It's super slow otherwise. Right. Now, I'm pretty sure we've done that already.
Okay.
Adam, the stuff we were talking about before with CPU usage, that's if they're not even on SSD yet, none of that probably matters. That was only in memory.
I think they are on SSD, or at least they should be.
Okay.
I think we should
I
talk
don't
about
know
this
the hardware details.
I think that's actually correct.
What was that, Josh?
We should talk about this in a different meeting.
Yep. All right. Thanks, everyone.
Talk to you later, guys.
Have a good one.